Hello everyone, this is our second lecture video for Chapter 7. The central limit theorem states the following. The sampling distribution approaches a normal distribution as sample size n increases to infinity. If sample size is greater than or equal to 30, the sampling distribution can be considered normal. If sample size n is less than 30, the sampling distribution is normal only if the raw score population is also normal. The mean of the sampling distribution is always equal to the population mean. The sampling distribution will have a standard deviation called standard error of the mean, which is sigma m, which is equal to sigma divided by the square root of n. The shape of the distribution of sample means is almost perfectly normal in either of two conditions. The population from which the samples are selected is a normal distribution, or the number of scores n in each sample is relatively large, at least 30, or n greater than or equal to 30. The mean of the distribution of sample means always equals the mean of the population. Your textbook uses mu m for mean of the sampling distribution, so mu m is equal to mu, or the mean of the sampling distribution is equal to the mean of the population. The mean of the distribution of sample means is called the expected value of m. M is an unbiased statistic because mu m, the expected value of the distribution of sample means, is the value of the population mean mu. The variability of a distribution of scores is measured by the standard deviation. The variability of the distribution of sample means is measured by the standard deviation of the sample means, and is called the standard error of the mean, or SEM for short, written as sigma m. The standard error of the mean measures the variability in the sampling distribution. It provides a measure of how much distance is expected on average between sample mean m and population mean mu. The formula for standard error of the mean is standard deviation divided by the square root of n. The law of large numbers states that the larger the sample size, the more probable it is that the sample mean will be close to the population mean. The smaller the population variance, the more probable it is that the sample mean will be close to the population mean. What is really cool about sampling distributions and the central limit theorem is that we can transform the sample distributions into z-distributions and calculate probabilities. So instead of looking at individual scores relative to other scores in the distribution, here we can look at sample means relative to other sample means in the sampling distribution. We can determine the probability of obtaining a particular sample mean, or how likely are we to obtain a particular sample mean. The formula, or the z formula for sampling distribution, is sample mean minus population mean divided by standard error. Remember that standard error is the population standard deviation divided by square root of n. This concludes our coverage for Chapter 7.